All right, hey guys, we're talking today about section 4.5, the slope of a line. So this is a clip from your book, How Steep is a Roller Coaster? You can describe steepness by a ratio called slope. To find the slope, we divide the rise by the run. In exercise 39, you will find the slope of a roller coaster. So we'll see what happens when we get there. So take a look at this triangle here. Here, remember, it's rise over run. So the vertical rise is 10, right? And the horizontal run is 5. So rise over run is 10 over 5. You always want to reduce a slope and keep it in fraction form. You never want to have a slope in a decimal. So this does reduce to 2 over 1, which is 2. So this line right here has a slope of 2. All right, so now we're going to talk about the slope ratio. Find the slope of a hill that has a vertical rise of 40 feet and a horizontal run of 200 feet. We always let m represent the slope. So here is my solution. M equals rise over run. Our rise was 40 feet. Our horizontal run was 200 feet. And remember, we always want to reduce this. So we're going to have, remember, you can just cancel out these zeros here. 4 over 20 becomes 1 over 5. So this slope right here, this slant right here, has a slope of 1/5. All right, the slope of a line. So the slope m, so m is the letter that we use to represent slope. Passes through these points, x1, y1. The little one just represents the first ordered pair. And x2, y2, the little 2, represents the second order pair. And here we go. We have this formula. So m equals rise over run, the change in y over the change in x. Right here is the formula for slope given two ordered pairs. You subtract your y coordinates in the numerator over your x coordinates in the denominator and be sure to reduce. I would like you to write this down. And please copy down that formula. So slope, when you use the formula for slope, you can label either point as x1, y1, and the other point as x2, y2. After labeling the points, you must subtract the coordinates in the same order in both the numerator and the denominator. Once I show you an example, that might make more sense. You can pause this video if you still need to copy down that formula or copy down how to use the formula for slope. So here we go. So now we're going to talk about example 2, positive slope. Find the slope of the line that passes through the points 1, 0, and 3, 4. So we're going to let x1, y1 be 1, 0. So here's my x1 and my y1. And we're going to let x2, y2 be 3, 4. So this is my x2, y2. Remember, the formula is y2 minus y1 over x2 minus x1. So all we need to do is plug in those values, right? y2 is 4, y1 is 0, x2 is 3, x1 is 1, okay? So just note that these right here, they came from the same ordered pair. That is very important, that the numerator and the denominator both start with the same ordered pair. So now we're going to simplify here. So 4 minus 0 is 4. 3 minus 1 is 2, and 4 over 2 is 2. So this line right here, this blue line, has a slope of 2. M equals 2. Remember, M is slope. We can always count units too when given a graph. So rise over run. So if we count up, 1, 2, 3, 4, count over 2, 4 over 2, it's 2, right? if I went this way, I could also do here, right? We could count up 1, 2, 3, 4. That's my rise. Over my run, 1, 2. 4 over 2. And you always want to reduce. So you can find slope using a graph as well. But for this lesson, for this section of the book, we're going to be using this formula right here. So make sure you write that down. All right, so what I want you to do is pause the video. You can find the slope of each of these lines. If you wanted to graph them, fine. I did put 3 graphs here. Not that you can utilize those, but I will show you what it looks like if we graph these points, and just to give you a general idea. So you can find these positive slopes. All right, so now I just want to show you something. So I did graph number 1 in pink, and I have a slope of positive 1/2. Graph number 2 was in purple. I got a slope of 3 over 2. Graph number 3 is in blue, and I have a slope of positive 4. If you're looking at a graph and you want to know if a slope is positive or not, just imagine that you are like you know how we read a sentence from left to right. So imagine you are walking along this graph from left to right. If you're going uphill, it's a positive slope. Okay? Just quickly visualize and see that. So now we're going to talk about negative slopes. So first off, here's my ordered pairs, 0, 3, 6, 2. We're going to let x1, y1 be 0, 3. And we're going to let x2, y2 be 6, 1. All right, now we're going to plug it into our formula, y2 minus y1 over x2 minus x1. So we have 1 minus 3 over 6 minus 0. 1 minus 3 is negative 2. 6 minus 0 is just 6. Remember, we always need to reduce, okay? So negative 2 and 6 both have a common factor of 2. So if we divide top and bottom by 2, we get negative 1 over 3. That is a negative slope. All right, so now you find these negative slopes in the next 3 problems. Make sure you pause the video and use the slope formula and check your work against mine. All right, so number 4 I have in blue, negative 1/3. Number 5 is in purple, negative 1/2. And number 6 is in pink, negative 4 over 3. So take a look at these graphs. They're a little different than the last 3 because now if we go left to right and we were reading a sentence, we're going to be going downhill. So clearly you can see that it is a negative slope. Okay, so let's talk about zero slope. That's something that happens too. So here's 2 ordered pairs, 1, 2, and 5, 2. So we're going to let x1, y1 be our 1, 2. Whoopsie daisy. Didn't mean to do that. Uh-oh. Okay. All right. I always like to write my x1, y1 underneath my ordered pair. You don't have to do that. It just helps me keep things in order. And then my x2, y2 is going to be my 5, 2, x2, y2. Right, and again, we're going to plug it into our formula. So 2 minus 2, right, y2 minus y1 over x2 minus x1. 2 minus 2 is 0. 5 minus 1 is 4. If you put in your calculator 0 divided by 4, you're going to get 0. I just want you to know that if 0 is on the top, that's okay. It's going to equal 0. I don't know if you want to write that down, remember that somewhere, but if the numerator is 0, the entire slope is 0. So what does a zero slope line look like? It looks like a horizontal line. Like if you can imagine walking on a floor that's flat, right? And there's no change because slope represents change, steepness of a line. So if there's no change, you have a flat line like this. Okay, well, that you know what I mean. That's a flat line. Let's all just pretend that's straight. All right, undefined slope, something a little different. It's kind of crazy. Here we have some ordered pairs, 5, negative 1, and 5, 3. So here's my x1, y1, x2, y2. Oh my goodness gracious, what just happened? All right, so now we're going to take y2 minus y1. Remember, minus a negative becomes a positive, so it's actually 3 plus 1 over 5 minus 5. Well, 3 plus 1 is 4. 5 minus 5 is 0. If you put in your calculator 4 divided by 0, you're going to get an error message. You cannot divide by 0, so this is undefined. Okay, another little quick way, a thing to remember I always write, if you have a number over 0, that's no, you cannot have that, it's undefined. What type of line has an undefined slope? A vertical line, right? Like, so if you look at your wall, wherever you are, unless you're Spider-Man, you're not walking up that wall, it's undefined. All right, so now we can look at these pictures, right? We have some information and we can determine if the slope is positive, negative, 0, or undefined, okay? So let's look at example 7. It's a horizontal line. It is a flat line. There is no change. If you wanted to plug in these points, let's just say this is my x1, y1, and this would be my x2, y2. I'm going to say 4 minus 4 over 2 minus 4. So that's 0 over negative 2, which is 0. So this is a 0 slope. 0. All right, let's take a look at the next line. So now we have a vertical line. All right, it's kind of crazy. I'm not sure if you remember the last slide or not, but let's just look and see if we plug in the numbers, right? I'm going to let 1 comma 4 be my x1, y1, and 1 comma 1 be my x2, y2. Plug it into my fancy little formula, right? y2 minus y1 over x2 minus x1. 1 minus 4 is negative 3, and 1 minus 1 is 0. We cannot divide by 0. This is undefined. Undefined. All right, let's look at this last one we got here, okay? So remember when I said if you're looking at the graph and you're going downhill from left to right, that's a negative slope. So we can see already that this is a negative slope. But we'll write negative here, and let's just plug in the numbers just to be sure. Right, here's my x1, y1, and my x2, y2. Okay, so I have 2 minus 4 over 4 minus 2. 2 minus 4 is negative 2. 4 minus 2 is 2. Negative 2 divided by 2 is negative 1. So this has a slope of negative 1. It is a negative slope. Oh, just kidding. All right, so maybe write this quick sketch down, okay? So a slope with a positive, or a line with a positive slope rises left to right, right? It's going up. A line with a negative slope falls from left to right. It's going down. A line with a 0 slope is horizontal. A line with an undefined slope is vertical. Okay, so here's your assignment for today, page 233 to 234, number 13 to 15, 19, 21, and 35 to 37. Nice, easy day for you. Make sure you write this down, and I'll see you later.